Hello, my name is Michael Yuan, and I'm really glad to meet everybody at PlatformCon. And so my talk is going to be automate R&D workflows using serverless functions. We're going to look at some, I think, fairly interesting topic, like how to improve your R&D efficiency using tools like ChatGPT and using serverless functions to connect them all. And my contact information is here, and if you're interested in getting in touch, you can scan the barcode here. It goes to my GitHub profile, where you can find my email and other things. Well, first, in my view, platform engineering has always been about two things. One is fully automated software delivery and testing, the CI/CD approach. It mostly focus on machine tasks, and it's because it's all about machines. It's fairly easy to automate. So you see things like GitHub Actions, and there's a lot of framework out there. And then the second aspect of it is, I think, somewhat difficult, and so it's about management, human in the loop workflows, meaning that you would have to, in those workflows, you have to involve humans, which brings in a lot more uncertainty and variety. And so as a result, it's difficult to automate, and it was less talked about. And this is the second half is a focus of this talk. So examples of this would be chat ops. That's humans interacting with the system to build and to automate the build. And the bots, a lot of people used to use GitHub Actions to build bots, but as we would see soon, really the technology is not really designed for that, because it's a virtual machine based solution. GitHub Actions is a virtual machine based solution, and so it's fairly heavyweight. And a lot of those human in the loop process are fairly lightweight. Say, sending an email, something like that. So to spin up a virtual machine for that is a waste of resources, so to speak, right? So so even GitHub is not encouraging users to directly use GitHub Actions to program those bots. So that brings up the question of what type of technology we should use, and how we should use them, right? So in my view, the platform engineering is mostly about reacting to events in the automated events in the R&D system. So for instance, issue being raised, or a patch being submitted, or commit being submitted to the code base, and then kick off a whole workflow, being the automated build and testing, or being the human in the loop process. So in that sense, it's very much like what we today call a serverless function. So it's a piece of code that reacts to some events in the system, right? So we're gonna talk about the challenge and solutions in this framework, right? Is that so if you think about GitHub Actions, it is a reactive action, and it's deployed as a serverless solution. Although someone does run the server, but it's on the GitHub side, right? For the users, it's you write a piece of code, you write a script to perform the CI/CD and upload to GitHub to you to perform those functions, right? So it's a serverless solution. Well, so like I said, that's the human in the loop aspect of the platform engineering has many challenges. That's why I think they are less talked about in conferences, and also in almost all the places, right? So the first is that it often requires interaction with multiple systems and services. So it's not like GitHub's actions in CI/CD, where you only interact with GitHub, right? That's you pull image and then you try to build it, and things like that. But with human in the loop, you have to engage where the humans are. The humans may be in Slack, or they may be they only have telephone, or and you would also interact with the humans in the language, or in the interaction mode that is easy for the human to understand, right? You can't just send commands. You would have to engage human in some type of user interface or user experience that is ideally natural language based. So there's a lot more complex interaction that you have to the program has to handle, which is not ideal for a computer program, right? And yet the logic of those things are often fairly simple and short-lived. For instance, it would be just someone raised the issue, and the system detects this issue is high priority, using some criteria. So you need to alert, the right people, right? That's so that would be a typical workflow. In that process, the logic itself is fairly simple, just detection and notification. But a lot of things you have to wait, you have to wait for the event to happen. And the detection itself or the messaging system to interact with humans are often asynchronous. So while it's a short-lived execution, but a lot of time spending on waiting for the network. So and also the type of business logic involved in those systems are often very complex. So those are that makes them very difficult to standardize, and also makes them difficult to build a simple framework that would handle all cases, right? So that's some of the challenges that we would encounter for this type of platform engineering. So the solution is really, there's a new advance in our field, which is ChatGPT. And ChatGPT makes it easy to create an engaging user interface for humans. So that by itself, it makes human-in-the-loop tasks a lot easier to program and to engage, right? And then, like I said, the serverless function paradigm has really taken off in recent years. And that interaction mode is mostly reactive. That is ideally suited for, say, for operations that are waiting for events to happen, right? Because it's a serverless function. You don't need to run it when there's no events happening. When there's some events, trigger event happened, the cloud, would magically run your function, which makes it a lot easier to manage those resources. And there's also new lightweight serverless function runtimes, such as WebAssembly, that are much lighter than, say, a virtual machine or a Linux container, right? That's so. For instance, for application that spend most of the time is waiting, that's to have a lightweight container like WebAssembly. You could have many instances of this serverless function in a single thread, right? You use something like the Go coroutine or Rust coroutine instead of having a thread, or even have a virtual machine that's running for each of the functions. So so at least in the past, I think 2 or 3 years, there has been a lot of technology advances that has made it possible, or has become enablers for this type of applications, right? So let's give a quick example of how those applications could look like, right? So the example I would show, including the code and all the interactions, the code review for GitHub pull requests, right? So the background of this whole thing is pull request is probably the single most time-consuming and the resource-consuming bottleneck that's in the entire development flow, especially for open source projects. Because the senior developers are very busy and very expensive, yet all the review work has to be done by senior developers. The junior developers or community developers has to spend, according to a survey, they have to spend on average more than 4 days to wait for PR to review and merge, right? So that is a huge waste of time on both ends for senior developer and junior developers, and also for junior developers. It's I would say for community developers, it also creates a very bad developer experience. That would make it really hard for because people tend to feel that they are ignored or they are not taken seriously if the PR takes a very long time to review, right? And the management also like to ask senior developers to come up with non-technical summaries and things like that, because they like to know what's going on and who's productive and what, right? So the idea, so this has become bottleneck for good reasons, because it's really in the past, because it's a human in the loop, it's really difficult for computer to perform this work, and to computer to perform this work in a way that connects all the system together, right? So the question really is, for all the technology development that I have talked about, the ChatGPT, the serverless functions, the lightweight serverless function runtimes, and things like that. Are we in a position to build lightweight and automated bot that can provide help and relief for senior developers? So let's give an example. So here is an example that's one of the community developers estimated one of the open source projects that I run. So it's a JavaScript function, as you can see here. The function is called check prime. And what it does is that it takes an integer number as input and want to check if it's a prime number. And we all know the prime number's definition is number can't divide, there's the only factor of this number is 2, is 1 on itself, right? So it's, so say 2 is a prime number, 3 is a prime number, 4 is not because it can be divided by 2. 5 is a prime number, 6 is not because it can be divided by 3 and 4, 2 and 3, right? So the way to check prime number is to start with number 2 and create a loop all the way to square root of n, the input number, the square root of the input number. Why it's square root, that's you can look it up, that's I wouldn't explain it here, but the algorithm is that try every single number between 2 and square root n, and if any number is divisible, then it's not a prime number because it has a factor. If none of those numbers are divisible, then it is a prime number. You can return, true. This is n is a prime number. So that's a fairly straight algorithm. And to be frank, if I were to write it, I'd probably write it this way. So the developer did it this way, which is fine. So then we have created a bot that has what we call ChatGPT in the loop, meaning that ChatGPT performs part of the work that a human is supposed to perform. The human senior developer is supposed to perform, right? So the ChatGPT gave a review, and so it identified some of the problems, right? So the first problem is identified. I'll let you read it, which when I saw it, it blows my mind, right? It says the check prime function can be optimized further. And it checks divisibility with even number after 2, which isn't necessary, So you can check all those numbers, but since it's not divisible by 2, it can't be divisible by 6, or 4, or 6, or 8. That's in retrospect, it's very simple, right? You can push the ChatGPT agent even further to say, in this case, you don't need to check multiple of 3 either, multiple 5 either. You could identify all the prime numbers in the loop and then do not check multiples of them. And that would lead you to a well-known algorithm that was discovered by the Greek over 2,000 years ago to have a more efficient way of checking prime, right? So, that's really is part of the power of what we call AI in the loop bot that would I wouldn't say replace the senior developer, but help the senior developer save the senior developer's time, right? So here is a very concrete example. So before I start to dive into the code, I would say that's how to get yours. You can go to flows.network and then clone a template repo, that's go through the template creation process and configure to access your GitHub repo and configure to give it, the Open API's API key. And you would be able to get your own bot. The bot would monitor the GitHub repo that you have set up. And for every PR and every commit in the PR, it would automatically review all the code that's contained in the PR and give you suggestions like the above as a comment in the PR, as the first comment in the pull request. So you would always have an up-to-date review of the pull request as the pull request grows, right? So let's look at some the example how it's achieved. So see, so here is how it's actually. So it's a real life pull request, and the bot sends a result, and the result was constantly updated with every commit that's being added to the PR. It would tell you what's the most important problems it finds and the findings, and then it breaks up into each commit and review each individual of them. And so let's look at how it works. So you can do this in JavaScript as well, but but in this particular case, the serverless function is written in Rust. So the step one is really this application runs and it waits for external trigger event. So it's a listen to event. So if you have written say HTTP server, you would see this pattern very well. It's listen at a port, something like that, listen for the event, right? So it would, from this point on, it would continuously listen for those trigger event from the GitHub repository that you have configured for it to listen. And then whenever a result is received, it would pass into the body of this function, and then it would call handler call the handler function and pass the payload into it, right? So in the handler function, to use the GitHub SDK to retrieve all the patches associated with the PR. So the PR information is in the payload, but then you use GitHub to the API to get all the information about the PR. And then for each patch, we send it. We use the ChatGPT API. We send to ChatGPT to review, to get a summary for summary result for each of the patch. And then we use the we send all the summaries to ChatGPT to summarize it again to come up with the overall summary. So that's all there to it, So you can see the serverless function is mostly about the business logic. And because it's written in Rust and runs in WebAssembly, so we can do it in a very high density, So meaning most of the serverless functions time is spent on waiting for, say, ChatGPT to return or for GitHub to return, for GitHub event to come in. And so we can literally run, hundreds of those functions in a single thread, right? Because all of them would be waiting, waiting for something to happen. When something happens, it's the listen to event. The method would receive some data, and then it would call handler, and then you would go right back to listen to the next event, right? So it's like it functions exactly like HTTP server, which listens to incoming port, right? So that's how it works. It is fairly easy. As you can see, there's a framework out there that allows you to do that. Once you have that, you can configure on the platform outside of the function. You can configure what are the events that are going to trigger it, how to set up, how to connect to GitHub, like I've just described, how to connect to GitHub and how to connect to the OpenAI side of the things, right? So here's another example, which is the previous example we gave is to review the PR commit by commit and then have a summary. But you can also review them file by file, and review all the files that has changed in the PR and then give a summary. So I know my time is almost up, so I showed the example, and I hope there's opportunity for you to explore further. But there's other things you can do with human in the loop serverless functions with this type of approach. So for instance, you can summarize GitHub issues, not just PRs. You can build a chatbot that answer project-related questions. You can train or fine-tune the language model to understand your code, your repository, and then people would be able to ask questions. They would be able to say, where do we find the check prime function? Where which file it is and how it's implemented, and the chatbot would be able to answer that, right? You could send the review or the result, not go back to GitHub as a comment in the thread, but you can also send that to, say, to Slack or to other messaging applications that people use. Yeah, so if you are interested, check it out. It's called it's open source. It's an open source organization. It's called GitHub.com Flows Network. It has a lot of examples in terms of how to create this type of serverless functions for platform engineering, and especially for tasks that has human in the loops. Right. So that's it. Here's my contact information, and I'll see you in the community. Thank you very much. Bye bye.